Zoom recording. Okay. Yeah, first of all, welcome everybody here. And this is our last summer coding group online meeting. And it's supposed to be the short meeting because we don't really see much of the project finished by different students. So let me double check, see how many students finished it. Okay. Yeah, I remember there's at least one post over here. I forgot. Oh, yeah, Kevin. Yeah, Kevin Zhao has one project post over here. I didn't see any other one. Let me see if I found any other project. Okay, so let's start. Again, this is our final project meeting, and I think we can make it short. Introduce our Youth Coding Innovation Club first. Everybody probably already go to this website. Let me just post one time. You can see what it looks like. In the future, if you have interest in, you can join our team, just see what kind of improvement you can make. Yeah, we have the news, we have the contest, curriculum, projects, clubs, forum, and login. And yeah, this is how basically it looks. And our coding club is really for 2021 summer. So yeah, we are officially over that period of time, but since it's last one, so we just give two more weeks extension, so it should be fine. Yeah, we break into 3 different groups. The beginner group, sorry. Yeah. The beginner group mostly use Scratch or Broccoli. Okay. And the intermediate group mostly use Java, Python, but I should also add JavaScript because there are a couple of demo project was really written in JavaScript. And hardware group is pretty much all kind of hardware. I can show you what kind of hardware we use later. Yeah, the theme for our last project, it's really about space explore. And just like everybody knows, the human history of space explore is very short. We used to really try to see what outer space looks like. And later we have some of this space explore, like space shuttle and rocket or all kind of device has been sent to outer space. And this theme is really use the imagination about how we can deal with different kind of space explore. We used to go to moon, and now we are really land on Mars. Hopefully the human can land on Mars soon. Okay. Now let's really make it quick. I will let Jason share his screen for the first project, space cleanup.
Okay. Can you see my screen?
Yes.
Okay, let me first go back to here. So, I mean, this one's kind of simple, but like, you can move the spaceship with arrow keys. So like I'm hitting the right arrow key right now until you hit like one of these items, and you could either click on burn or bring home. So bring home just brings it back to Earth, and then burn will like have that animation. Yeah, that's about it. And then if you look inside the code, first the spaceship always goes to this location in the bottom left, and then if left arrow key is pressed, then change X by -4. If right arrow key is pressed, change X by 4. And if up arrow is pressed, then change Y by 10. And then if it's touching either this color or this color, then it'll broadcast a message. And those colors are just like this yellow from the taco and then the gray from the rock. And then when it receives message 1, it says this message to ask you what you want to do. And then for the taco, first it switches to a costume. And then it sets size to 50% and it goes to somewhere random. So it could be anywhere on the screen. And then same thing with the rock. It's pretty much the same thing. I'll get back to these message when I receive message 2 and 3 after I go over this. So basically when it receives message 1, this is when the spaceship touches one of the objects. So when it receives that, it'll show, which let me show you. It's on the top of the screen. And then when the sprite is clicked, when the burn button is clicked, it broadcasts message 2. So this is like left click, right? You can see. And then when bring home is clicked, it broadcasts message 3. And the earth, there's no code. It's just like in the bottom right. So when it receives message 2, if the taco is touching the rocket ship, then it points towards Earth, and then 100 times it will move this way and it changes the color effect so that like makes it look like it's burning, and it also changes the costume. And then if it receives message 3, that's bring home, so it will just glide to Earth smoothly instead of like that burning effect. And it's the exact same thing for the rock, but just for the other sprite. I could like show it one more time. So that's like the changing color effect. You can see like it's changing colors. And then bring home, it just brings it back to Earth.
That's very interesting. Okay. So it sounds like it should not be too challenging if we want to add more object over there, right? So besides taco and rock.
Yeah, you just, yeah.
So just in case we want to add another like maybe alien over there, just make up. So what's a step we should do? You do not have to finish it. Just give us some basic idea.
Probably just make a new sprite with like that looks like an alien, and then I mean the code is pretty much the exact same thing, because it should behave the exact same way.
Yeah. Okay. Do we have to create multiple costumes for one sprite? I mean, if we want to add one sprite over there.
Yeah, you can see the costumes. One of them is just the regular rock, and the other one's like it's burning.
Okay, so they have two different ones for the regular one, another is for burning. Okay, that makes sense. That's very interesting. Okay, yeah, that's great. Thank you. Yeah, let me see. Next one will be Yuyang's demonstration. I don't even know how to spell that name. Shaun, Shaun, the ship. I believe that's some sort of movie. Yuyang, do you know what's that?
I don't know.
Okay, yeah, that's okay.
Let me get it up. Hold on a minute. Let's see. All right, can you see it? I think you can. Okay. Yeah. So let's take a look at the project first here. So I'll just let it play out. So you can see that there's not much interaction.
Yeah. So they are really trying to build a story over here, right?
Yeah. There you go. So let's take a look at how this works. So here's the Sean character first, and this is what it does at the start. It just initializes some variables. And I show the name variables to the second variable, and we're going to count up the number of seconds to make that clock on the top left work. That just does that for the whole entire project. Now I was going to explain this, but it's a bit complicated on the first scene. So if you can see on the first scene, we have 3 characters that are moving. We have Sean, the spaceship, and the other character on the right. So let's take a look at this. So here we have the script for the other character, the spaceship, and Sean on the right. And at the bottom you can see Sean, it broadcasts message 1. So I also got the code for that, and that splits off into 2 paths right there. So there's an arrow to mark that. And to make this a bit clearer, I put a little arrow here just to see where it syncs up. So first of all, the other character on the right, it goes to -200 by -100, which is the right of the stage. And then it glides 2 seconds, which makes it appear to be going into the spaceship, and then it hides. So it sort of makes it appear that it's in the spaceship. The spaceship, it goes to the middle of the stage. And then for 200 times, after waiting 3 seconds, that means that's after the characters that enter the spaceship, it's going to go up and away by changing the size to -5. So it appears it's going 1. And Sean, what he's going to do is he is going to, at the start, he's going to go to the left of the stage. He's going to switch costume to the floating costume. And then here is where it branches off. So these happen simultaneously. So he's going to start spinning, right? Repeat 60, change. Sorry, no, this is going up. Repeat 60, change y by 5. So he's going up and away. And here, this is after this backdrop has switched to the stars. Then he's going to keep going up after we switch the backdrop to the stars. And here, this also happens simultaneously. This makes Sean spin. And then he's going to glide 1.5 seconds to the top left of the screen. So he's going away. Here is the second scene where Sean arrives at this barn scene. So here we're going to go to the correct place, which is the top left. So he starts floating down. He's going to glide into the ground. And he's on the ground. It just moves in a little bit, so he appears he's on the ground. And then he's going to get up by pointing in these directions, and he's going to change the costume standing. And then he's going to broadcast 2. And what 2 is that he's going to run. So he's going to play the animation running. He's going to change the size so that he appears further away while running. And note that this happens simultaneously, by the way. So as he's animating, he's also getting smaller. And he's going to also glide to the barn door. So everything happens simultaneously here. And he's going to say knock, and that's really it for that. Here, the barn. We're going to switch the backdrop to make it appear that the barn door is open. We're going to go inside the door by gliding, so he glides to where the door is open, and then he switches to the room backdrop to appear that he's in the room. So here's this scene. Here's the room scene. We are going to, so basically Sean here, he only reacts to stuff in this room since it's player input. So the 2 main things that we can do in this room is that we can click the glass so that Sean will drink the water. And when the glass is clicked, it broadcasts 4. So he glides to the water. He broadcasts eat, which causes the glass to change to an empty state. And when space is pressed, he leaves the room. And he also broadcasts come. I'll show you what come does in just a moment. So here is the broadcast come. This is the other character. And he's going to move and just say some messages. Say, someone drink my water. And they're going to switch the backdrop to Greek theater. So this is the third scene now. So when the backdrop switches to the Greek theater, he is going to switch his standing. Sean is going to switch his standing. He's going to set size to 60%, so it appears that he's inside the theater. And he's going to go to that position, which is inside the theater, and he's going to broadcast something Greek. And what Greek does is that when the other character receives Greek, he's going to go to the inside that theater, and he's going to say, "You drank my water." And then when he says that, he's going to broadcast chase, and then Sean is going to say, "Oh no, I better run." He's going to broadcast, "Oh no," and then he says, "Why did you drink my water?" Broadcast tell, and then tell asks the player, "I drank your water because blank," and it asks the player to fill it in, and he's going to broadcast ask. And then after this, it's going to check, "You drank my water because," and it's going to concatenate the answer. And then he's going to leave. And then when Sean receives the message leave, he's also going to leave the Greek theater and hide. And that's it.
That sounds very interesting. Yeah, it's, to be honest, it's a little bit more complex than what I thought. So by your explanation, if we want to create a story, use a Scratch, what's your suggestion to start, and how can we start? Yeah, it seems like this is a perfect example about how to create a story, right?
I'm sorry, I think someone's talking. I can't hear you very well.
Yeah, I see. Yeah, some background noise. Let me mute them. Okay. Yeah, my question is, okay, seems like this is a great example for storytelling, right?
Mm-hmm.
So I saw you explain from the beginning to the end. So just in case we want to create a totally different story, so what's your suggestion where we can start? And
well, I think
what's the most important component we should grasp?
Well, I think you should start first by just like planning it out in scenes. And then like each scene, you map out the character, what each character does, and then you start building it. Because in Scratch, if you start building it and want to make changes, it's kind of hard to.
Okay. Yeah, I see this send message back and forth. So looks like multiple character or multiple sprite here. They need to exchange the message. So they can really, just like what you said, sometimes they can simultaneously do one thing and change the size on another side. And sometimes they just send message and wait for a couple of seconds, right? So they just try to create some sort of animation, right?
Mm-hmm.
Yeah. One thing I think a little bit more advanced is that I know Scratch can support text-to-speech. So if you can, would you mind to show us how we can add that extension, and then maybe just speak of one of the phase, use the text-to-speech.
I hold on a quick moment while I get that up. Let's see here. All right, so I have a new Scratch project here.
Mm-hmm.
And what you want to do, because currently you don't see any like text-to-speech stuff in these. So if you look in these, you don't see any text-to-speech box. So you need to go down here, to the bottom left, there's an add extension button. It's blue, it's the icon of extensions. And you can see there's a bunch of other extensions which are really cool. And we are going to select the text-to-speech extension.
Right.
And click it. And then now you can see the text-to-speech blocks. And you can see these can just be used as a normal block. We can say hello. We can also even put a variable in it so we can say what the player entered. So, and yeah, that's it. And if we also want to change the voice, we can use this set voice too. And we have these voices. And there you go. It's really simple to use.
Yeah, I see. You can even set a language to different language, right?
Yeah.
Wow. That's fantastic. Okay, so probably some of this project, we really like to use this text-to-speech, which makes a lot of sense, especially when you create some sort of project for the storytelling, right? The character can speak out something, some sort of message. Is always better than just show what the message looks like. Yeah. Okay, great. Thank you so much. Thank you. Yeah, let me share my screen. I guess that's a beginner groups project. And I know we have one project from beginner group, and that's from, let me see, what's his name? From Kevin Zhao. Is Kevin here? Okay, I didn't see Kevin Zhao. I see Kevin Huang here. Let me see if I can open this one, just in case. Okay, great. So let's see inside. Okay, yeah, I go to some. I put over here. So let's just give the credit to Kevin Zhao. Okay. And just see what kind of projects. I will not explain it because I don't have time to check it out before the meeting. So I just try to play it, see what we can do. Launch. Oh, okay. I flipped it over. Seems like, oh, okay. Yeah, the code is here. And just in case have interesting, you can check it out. Yeah, this probably just change the size and change the effect. Yeah, okay. Yeah, they change the visual effect here and receive the message. Okay, so that's something, yeah, we can take a look later. Okay, now I will ask Jason to share the screen for the, okay, Andrew, what's the question?
I didn't have time to do my sketch project. Sorry. It was like, I had other stuff to do.
What's your question? I'm sorry, I'm not quite catch you.
I couldn't do my sketch project in time, the space project, because I didn't have enough time.
Oh, that's okay. Don't worry about that. Yeah, just in case you finish the project later, you can post on the Google Classroom, and I will post on the GitHub. Okay, I will post over here. Okay, so I will stop sharing my screen and ask Jason to share his screen.
Okay, so this one is like another quiz similar to the Olympic one. It's much shorter though. So basically it's just like you choose a random planet with moons and you have to, if you know like one of the names of the moons, you could say it. This one's a bit unlucky. It's just moon because it's Earth, right? It only has one moon. But like for other planets, I actually don't know any of. So let's put in Ariel, right? It'll say like, congrats, you got it right. Or like Neptune, actually don't.
Yeah, it's very hard. I don't think.
I know like maybe like one Saturn moon and some Jupiter moons, but like that's
Okay.
it.
Yeah.
Let's see. Yeah, so Saturn, I think it's like Titan or something. Yeah. From making this quiz, I remember Mars. There's one called Deimos. Like, yeah, so I'm gonna go over the code now. So first, this is just like setting up all the correct answers. So there's a solar system class, which will hold all of the planets in this self.planets variable, which is a list. And there's an add planet function that passes in a planet, and it basically just appends that planet to the list. And then the get planet function, it takes in a planet name and it loops through all of the planets in the list. And if the name equals the name of the planet object, then it will return the planet object. Otherwise, it will return none. And then the planet class is how you create the planet objects. And when you create it, you pass in the name and the moons. And the moons is just like a list of all the moons, like you can see here. And then this double underscore string method, basically in Python, whenever you call the function str for string, and then like you pass in a planet, in like when you type this, what it's actually doing, it's calling this double underscore string method. So basically this just returns whatever it will print out if you just type this. So that's what that method does. It's basically just the name of the planet and then a space and then the list of moons. And then this get moons function, it just returns the list of moons for that planet. Get name returns the planet's name, and add moon will add a moon to the list of moons for that planet. So first we create this our solar system object, just using an empty solar system class. And then we call the add planet function for the solar system, which is over here. We add in a planet object, and the planet object takes in 2 arguments, which is the name and the moons. So the name is Mercury, and Mercury has no moon, so it's just an empty list. And we do this for all of the planets. So like Mars has 2 moons, Deimos and Phobos. And then Jupiter has like a lot, and Saturn too. And this is just adding all the moons, right? And I guess Pluto's in here too, because it has a moon as well. And then the actual quiz itself is very simple. First, we import our solar system from this file, the classes file. And then we also import random. And then it prints out this opening statement. And then, okay, so inside of the planet variable, we store this expression, which is random.choice. And then we pass in a list. So random.choice, basically, if you have a list of, for example, 1, 2, 3, 4, it will just randomly choose one of these. So it could be anything from 1 to 4, but obviously we're not doing numbers here, we're doing like planets. So it'll actually be like something like that, right? And it'll choose one of the planets. So this part here, P for P in our solar system of planets, if length of P dot get moons is greater than 0. So basically, in short, this is just make a list of all the planets in our solar system if they have more than 0 moons. So like if they have any moons. So that this way it won't ask like name one of Mercury's moons, but like Mercury doesn't have a moon. So, and the answer is the input, name one of, and then we put in the planet's name, moons. And then this answer.title basically just capitalizes the first letter. So if you have something like, if you typed in this, it'll basically change it to this, because if you can, as you can see, like all of the moons start with an uppercase letter. So we don't want to say you got it wrong if you actually did, but you just didn't put the uppercase. And then if this new string is in the list of the planet's moons, then that means you got it right. Otherwise, it's not one of the planet's moons.
That's very interesting. Yeah. Are you able to demo one more time? Just see if we accidentally enter something wrong. How it works?
Yeah. So if we put in like Saturn's moon, for example, which is not, it'll just say that is not one of Jupiter. Like it'll like change. This will change depending on which planet it was.
Okay. So actually, it will get exit. They will not really continue ask you.
Oh yeah.
You have only one chance for you to give it a try, right?
Yeah.
In the code, if we want to increase the chance for like multiple try, like 3 try, where we supposed to add the code?
Yeah, so it's basically like the Olympic quiz that I showed last time. Maybe you have like some sort of variable, right? That tracks
Okay.
the number of attempts. And then you use a while loop. So like while attempts is greater than 0. And then you would use that to keep track.
Okay. So you can set maximum attempts and then you keep track of how many attempts you already tried. Okay, great. That makes perfect sense. Okay, yeah, thank you. I think next one is Yuyang's demo for, I think the JavaScript program.
Just hold on a moment while I get that one out. Let's see here. Let me share my screen. All right, so here is the project that I'm about to show today. So this is a game, and the objective of this game is to try to, you see this like lander here, you're supposed to try to, sorry, I just accidentally advanced it. You're supposed to try to try to make this lander as slow as possible when landing. So, and I believe that it has to be below, I think, 4 meters a second. And you can see that down on the bottom right. It's a bit cut off by the screen recording here, but you can see 38, yeah. That's way too high. And the way that you do this is by turning on the engine on and off. And if you turn the engine on, it's going to slow how fast lander is. But the engine uses gas, and you can see that down here, the kg amount of gas. So if you have 0, you can't use anymore. And I didn't succeed here. So let's take a look at how this is done. So here's the JavaScript for this. We are going to get the height of the canvas. This is just initializing some variables to get the canvas variables so we can interact with them. This is the area from the side of the spark to clear, so we know like the boundary, so we don't like accidentally clear the whole entire screen. The zoom factor. This determines if the game is paused or not. When you pause it, it's true, and if it's unpaused, it's false. This is the delay from which you start. Basically, what this does is that it like pauses it for a moment so that we don't show the replay message immediately. And this is the timestamp at which physics was last simulated. Now, this is a bit complicated, but this is used for timing purposes, and we're going to see what this is used for a little bit later. And here's also the gravity settings, how fast the gravity goes. So you can see this is very like modifiable. The interface spacing settings, that's self-explanatory, how big the stars are, and also how big the mountains are. And here's the surface position. And you can see scaling factor used there. So if I change to scaling factor, it would affect where the surface position is too. Let's take a look at the lander now. Here's a lot of variables. Basically, here's the width and height for the lander, some initial settings, including the altitude, the velocity, and fuel, so I can change that if I wanted to. The lander thrust and fuel setting, rate settings, or how fast it burns through the fuel when the engine is on. The initial position of the lander is set to the start lander altitude, and also the fuel amount. You also see this lander mass variable here. Basically, what that does is determines how fast the lander is going to fall. So obviously, if you have more mass, you're going to fall quicker. And this is determined by the land mass dry plus the amount of lander fuel it has times the lander fuel unit mass. So it's calculated based on the fuel you have. So if you use up all your fuel, then you're going to fall slower. Here's the won and lost variable, some image definitions here. Let's take a look at how it registers the events. So on resize, we can call handle resize, which just makes sure that the canvas is in the window. We'll take a look at this a little bit later. We're going to turn the engines on and off when we press a key and release a key, and also for mouse down and mouse up, and also for touch screen, so it's compatible. Let's take a look at the start function. So here we're going to adjust the canvas size, and we're also going to set some default variables. You can see the start lander altitude, that's from before. So here is the huge handler resize function. Let's take a look. So we're going to make the canvas fill the window by making the canvas width equal to the window width. Set the surface position. It's times the scaling factor, so you see it again there. It affects basically everything here. We're going to set the canvas stroke to set it to white. So when we're drawing, we want the lines to be white. And also we're going to clear the whole entire screen and set the line width to 2. We're going to determine the star density by doing star density times canvas.width times canvas.height. So basically it's the size of the canvas. If the canvas is larger, that means the stars are going to be larger. So it automatically adjusts for that. And it takes star density into account. So if we change that, it also does it. And for each star, we're going to make a star. And we're going to determine that using math.random. Let's take a look at the surface that it's going to draw here. We're going to move the pen to surface and we're going to draw a line. And then we're going to decide on amount. And that's just the surface. It's like a straight line. And then if we want like bumps in the surface, we want mountains. So here's where we draw the mountains. We're going to decide on a random number of mountains. We're going to change the fill style to black so the mountains are not see-through because then those would be weird. We're going to decide on the point where there is no mountains because the lander, right, you have to make it so that the center of the screen has no mountains so the lander can like actually land. For each mountain, we are going to decide on a random mountain position and size, math.random yet again, and it takes into the ideal mountain width into account here. And then for each of these mountains, we are going to, if the mountain is not in the no mountain zone, which was the exclusion zone that we calculated earlier, we are going to draw a line for the mountain. And for each of the mountains, we're also going to fill in the mountain so that it's not see-through. You can't see the stars behind it because that would be not right. Let's take a look at what the physics function does. So if the game is paused, we don't do any physics because it's not supposed to be falling. And here's where we take the last physics timestamp into account. So basically, this physics function, right, it doesn't get run on a set interval, so we can't do that. Instead, we have to just set when we last did the physics so that we can calculate how much time has passed so we can move the lander the appropriate amount. So here's where we set the physics timestamp to the last time we calculated it. If the engines are on and it's not paused, we are going to subtract fuel. If we're going to update the lander mass since the fuel has now changed, so we want that to be accurate. We're going to also calculate the new amount of gravity, and this is based on the lander mass and also the lander thrust power. If it's on, then it goes a bit slower. And then we're going to change the lander altitude. If the lander altitude is 0, we're going to check the velocity and the sign of wind/loss that is. And here's the number. If it's less than 4.5. And we're also going to calculate when the new restart time. Let's take a look at the animate function now. Here's where it draws everything on the canvas. I'm going to set some positions, including lander height and the lander position. We're going to calculate these. And then if it's not paused, we're going to clear the lander area so it can be redrawn. Clear the status area so it can also be redrawn because canvas it's not like Scratch. You can't just move the sprite. You have to actually clear it first and then draw the new position for the sprite. So it's a bit different than Scratch here. We're going to call the physics. We checked that out a little bit before here. If it's not paused, we're going to draw the image of the lander where the lander is supposed to be. We're going to draw the image of lander with engines on if the engine is on. We're going to generate the text for the status bar, and we're going to do for each of the texts, we're going to put the text on screen with context.fill text. And then here's the won/lost status display. So if we've won or if we've lost, we're going to we're going to draw the text. And then if we're ready to play again, we're going to press any key to start the message. And really that's it. And this function tells the browser to run this function a little bit later. Oh, and here's also the HTML. You have to do that. So here's the title page, lunar lander, some CSS. The background of the page is black. The graphics are drawn into this canvas element that fills the whole entire screen. And there you go, that's it.
Okay. Would you mind to demo one more time? Just see how it's running. Looks
Yeah.
like.
It is.
So when it's drop, you can really start to fire, and then they can slow down a little bit, right?
Mm-hmm.
But you have limited fuel, so you cannot really always try to push it.
Yeah.
Okay, now it's burned. Okay. So its crash is because its speed is too fast, or it's because
Yes. Because the speed is too fast. You can see down here it's a bit cut off. It says 19 meters. It has to be below 4.5. I think that was what it was.
Okay, it should be below 4.5 meter per second. So it's because the speed is too fast. Okay.
Yeah.
So the tricky part is that how to balance how many fuel you will use and the speed. You cannot really slow down too early, but you cannot slow down too late, because if it's too late, it's over the speed limit, it will crash. But of course, if you slow down too early, you will run out of fuel, right?
Yeah.
That's very interesting. Okay. Yeah, thank you so much. Thank you. Let me see. Kevin, are you here? Kevin Zhao. Yeah, I will let you share your screen, and then you can.
Right now? Right now?
Yeah, you can show us what's your project. I believe you finished one project, so yeah.
Okay.
Hello, Kevin. Are you here?
Okay.
Okay, great.
I can't share it. You disabled participant sharing.
Wait a minute. I make you to be the co-host, so you should able to share. Yes. Try it again. Oh, I'm sorry. I give Kevin Hong. I got the wrong person. Okay, sorry.
Okay, yeah.
Let me see. Kevin Zhao. Okay, yeah, you're okay now.
Anyway, so okay. So then you can do that. So then you can go into like a super speed mode, where you can go extremely fast, and you go past the asteroids. It's impossible to actually survive the asteroids. So you have to go. So it automatically puts you into an escape pod, and then you have to go to Venus and to repair yourself. Once you come out, then you'll be a little bit far away from Venus, and then that's the sun. You go to the sun, and then you just start orbiting it. It was very low quality.
That's okay. Yeah, we really like to see how the code looks like, how it was put together. If you can see inside, yes, great. Just tell us what's the main sprite and how it works, how the code put together. So you probably like to explain the rocket ship a little bit, so we know how rocket ship works. Hey, Kevin, you mute yourself. Let me unmute you.
Oh, I was muted. So the rocket ship has a bunch of stuff here. This because if touching there wasn't very effective, so I did it. If touching the black border, it teleports to the next scene. So you see this when it's pressed in the escape pod. If P pressed, broadcast repair engines in the rocket ship. When it's received, it will do this coding. It will show, it will switch costume to launch, point direction 90, and it will glide upwards. And then it broadcasts, let's go to the sun. So then the sun is near, will show.
Okay, so that's the end. Oh, you stop sharing. So you finished?
Yes.
Yeah, I'm sorry, I didn't see you close your screen. Probably you already stopped sharing. But anyway, yeah, if that's it, it's okay. Yeah, you demonstrate the main part of your program. Yeah. So let's see. Intermediate group student demo, we don't have anybody finish anything yet. So let me show you some of this hardware group project. Since we are not really doing the physical project over here. So let me share you the YouTube video we created before. Yeah, this is really a project with a 3D printer. You know, this is an astronaut, and then this is a robot car. Actually, this is MBOT, but it's not really looks obviously because I print out something put in front of it. Yeah, it was done about 2 years ago. So that's really the human moon landing 50 years anniversary. So, okay, that's a very short and small demo. And I also saw another demo. It's not really much about the real demonstration, but it's really like the event.
Certificates provide
report.
online training for in-demand
Sorry.
jobs. Train for jobs in.
Okay, though they may not actually
It's like a
remember the
report.
moonwalk themselves, these middle and high school students are celebrating the 50th anniversary in a very special way.
NASA's Northwest Earth and Space Sciences Pipeline hosted their Robotics Challenge at the University of Washington today. 28 teams from all across the state programmed robots and drones to land on a map of the moon's surface. And using a Lego Mindstorm 83 robot, they explored, sampled some moon rocks as well. Come on, make that landing. There you go. The goal here, to prepare a new generation for the next leap for humankind.
Yeah, that's a very short video. Just to report what the hardware can do. You see there's a drone, there's a robot car over there. Yeah, there are a couple of very interesting projects. But yeah, I don't really show you the rest of that just because we don't really have enough details. Yeah, again, this is a competition, Make X Robotics competition, North American Open. I know there are a couple of students here joining that competition. Like, yeah, Andrew, I think Andrew is there. Yeah, it should be a very interesting competition. I will not replay this video just because you probably already see this video before. Again, this is a summary. We will post all of this project on GitHub page, like here. So far, this is a demo, but I will post Kevin Zhao's project over there. It's a great project. Yeah, and all of this will credit back to your name. And I encourage you share your message in the Google Classroom. And of course, you should able to demonstrate your own project if that's possible. For the whole summer project, we finished 5 projects. The very first one is Father's Day gift, and the second one is American holiday, and third one is board game is fun, and third one is Olympic glory, and today is the last one, Space Explorer. And just to show you how we are doing, so I have the Max pen here also. Okay, so we have this much of the student finish at least one project. Andrew Liu, Kashi Chai, Baham Jan, Juwan Wu, Sophia the cat. I believe this is not a real name, but anyway, you have to contact me in case you want to get the certificate. Asena and Max Penn. I believe we have a couple of students here. Yeah, Andrew is here, Kevin Zhao is here, Kevin Hong is here, and Richard's not here, unfortunately. Yeah, Michael Wei is also finished something. Ray Pan, if you finish anything, just let me know. I really like to give you chance to get a certificate. Yeah, I believe Max is here, Max Pan, right? Okay, so yeah, all of you, as long as you finish at least one project, you will receive the certificate. And Yuyang and Jason, you will receive the volunteer certificate. Really appreciate. Yeah, you did great job. Especially every time you were prepared and you really did great job to explain that. And sometimes you have something which we feel surprisingly new. And I mean, even for me. Okay, and that's really what our whole summer coding group project. And if you have interesting, you can go to this link of the GitHub. I believe this is very important. Let me explain a little bit. Okay, I have friends, they are looking for job, sometimes looking for internship, sometimes looking for full-time job. And they are really take a look at of what kind of project and how many projects you post on GitHub. So that become very important. Even some of this prestigious college, when they give them, for example, scholarship to the new student, how can they know you are really the right one to receive that scholarship? They will check your background, of course, see what kind of competition you come through, what kind of project you are done, but you cannot just claim what you are doing, right? You need some data to prove that. So, you know, the whole world is built around the data. So the GitHub really is the best place for you to showcase your project. Just like we have the American Holiday, you see there are multiple students finished project, right? Kevin Hong, Andrew Liu, Asana, Max Penn, and Richard Xu. And then the second project is, I'm sorry, that's the second project. The first project, Father's Day project. I'm sorry, I forgot some of this name put over here. I can change it. But anyway, Max Penn got the credit over here because your project was posted over there. And the third project, Sport Game is Fun. We have Richard Xu, Andrew Liu, and Asana. Okay, every time I post the project, I make sure I use your name. So that's a credit back to you. Also, the fourth one, Olympic Glory. And we have the Beham, John, Andrew Liu, and Cassie Chai. And yeah, I'm sorry, I forgot to post Jason and Yuyang's project. I will post it, so don't worry about that. And the last one, it's really only the Jason's and Yuyang's projects here. I will post Kevin Zhao's project. So yeah, just remember that in case you finish the project, which is not listed over here, let me know. And I will definitely post that, use your name, so you will get credit. And yeah, again, this is a great experience for the whole summer. We start around June 20th, I believe. And then we'll end a little bit late, September 12th. We're supposed to be end by September 6th, but 1 week late. Anyway, that's okay. We finished total 5 projects, and we have more than 50 students participate at different level. And I believe we have over 10, maybe 12 students finish at least one project. So yeah, really appreciate you, and especially appreciate Jason and Yuyang. You did great job. And I'm really so proud of you. And that's pretty much wrap up our summer coding group. And with all of these 5 projects, in the future, probably we will host some sort of coding, not club, coding league, So we'll participate in the national-wide or even international-wide coding activity or competition. So yeah, if we have any chance, I will post in the WeChat group, comes through the email list, and hopefully you can participate and enjoy that. I know coding is not always easy. Sometimes it's not easy, even very challenging. But the good part is that, like what you can see, you can always see the result, and it's fantastic. Yeah, I believe you can enjoy through that journal. So yeah, again, appreciate everybody come over here, and I wish you have a great Sunday night. Yeah, bye.
Bye.
Bye.